Are we live right now? Just tell me a small hi if at all we are live right now. So are we live? Just 1 minute, one small minute. Just I need to check that are we live, yes or no. So are we live? I'm just waiting for your what we say chat in the description. So are we live right now? Just 1 minute. So yep, I think we are live. So hey guys, how are you all? How are you all? How are you all? So how are you all? So just give me a small confirmation if at all you are able to hear me properly right now. So hey guys, how are you all? I'm not able to see anything in the chat right now. I don't know why you guys are like not typing in anything.
I think we are not live.
We are not live.
No, I cannot see anything on YouTube.
Yeah, it is showing me that we are live actually.
अरे बाबू कुछ अपना गलती हो गया है. Just कहाँ से आ रहा है कनेक्शन? Shit.
I'm just shuffling it.
Just one
Okay.
minute. Just 1 minute. I'm doing it. Just 1 minute. Tension not.
Okay.
Sorry. Day two. Alarm people. Save changes. कनेक्शन कहाँ से आ रहा है ये वाला?
Second day second से हाँ इसके.
ये ऐसे कैसे हो सकता है ये? How is this possible?
I'm completely clueless right now, but I'm also trying from my side.
अरे पहले वाला वो बंद हुआ कि नहीं हुआ वाला?
And that is stopped. That is stopped.
पक्का stop?
Done. पक्का.
नहीं ये क्या हो क्या रहा है ये?
I'm not getting it. Wait, I'm not getting it.
मैं दोनों को. Okay, hey everyone. I hope that right now we are all set to go live. Okay, so actually we are like facing up a small problem with our like I don't know, this our system was like not able to show us live. Okay, so hey everyone, good morning, good evening, every one of you. We are actually tend to do all the sessions in the morning time. So right now we are doing all our sessions in the evening time. That was the thing. So good evening, every one of you, and I hope how are you all? So how are you all, guys? Just tell me a small hi in the chat right now. I'm Sai Kiran, and I'm just welcoming you all guys to this session of cybersecurity day 2. So how are you all? So just put up a small hi if at all you guys are able to. So hey, you guys are able to hear me up. So we are live right now in the YouTube. So I'm not seeing any kind of chat coming in today. Okay, so I'm able to see the chat right now. Hi, hello. So yep, guys. So now I hope you guys are like fully fine at your places in this COVID-19 situation. And can you please raise your mic volume? If you want me to like raise your mic volume, actually I'm speaking very slow today. So yep. So how are you all? So okay, so now too tired just coming from AWS. Okay, see, I'm also like coming from AWS. Just now I ended a session there, and now even don't worry, guys. If it is your first session, just go and watch our like previous session, which is there in the description, and just go and fill the attendance form for like day one first, then day two. Okay, so you have to do that all things religiously. And now I would like to hand over the session to our Professor Vinayak Gupta sir. So, sir, like we are all set to take our today's class. And so, I mean, can you share your screen, sir? Yes, I think we are all ready to share. Like we got the screen share, and so just a small zoom will do. I mean, if at all you will zoom it out now, so it would be good. Actually, we're not able to see anything. So little bit more, sir. Like 100%. Yes, little bit, one more 10. Yes, I think 100% chale jayenge. Yes, now it is all okay. Now we are like we're able to see that. Okay. So hey guys, I hope that you all guys are able to see our like this screen. And can we go ahead? Can we go ahead? Just give me a small high five in the chat right now, and we will start our whole session for the day one. And right now, I'll be not available in this session, so Binak sir will be there, and he will be looking into the chat. So you're able to see the chat, right? So Binak sir, you're able to see the chat,
Yeah,
right?
I
Chat.
am able to see the chat, right?
Yes,
Okay.
yes, yes.
So hi
Okay,
guys,
guys.
hi everyone. Welcome back to the show. And we are ready to take off with VLSM and CIDR today. So today we are going to deal with IP addressing and all, right? So stop sending in messages on the chat and just listen to sit back, relax, enjoy, and watch the show. And
Yes, sir.
so we have today about something about IP addressing. We have something about VLSM as well, and we have something about CIDR as well, right? Let's go over here and first of all understand what is IP address. So any IP address is exactly a logical address that is put up inside a computer system, right? So those who are not aware of the IP address, so where do we put in IP address? So first of all, let them show where we put up the IP address.
So small. I mean, sorry for the interference. I mean,
Yes.
can you just, please, I mean, zoom it out a little bit more? Actually, on the screen, it is very pixelated.
Okay, on the screen it's very pixelated. Okay.
Yep. Actually, a little bit more zoom would do. Hey guys, please tell us in the chat if at all. Just like say 150, is it okay? 150 percentage, is it okay? 150. Yeah. Now it is all fine. So now I hope that everyone can see this. Okay, sir. So now we can go ahead.
Okay. Thank you so much for that feedback.
Thank you.
So, for those who exactly are not aware of what an IP address is, first of all, let me exactly make them aware that where we put in the IP address, first of all. So, let us take up a Windows system because people are aware of the Windows system over there, right? So, we'll take up a Windows system and we'll power it on. So, this is a VMware architecture. So, how is this architecture working in all? So we'll learn about that in a later chapter. But today's agenda is to make you understand how the IP addressing works, right? So first of all, we'll open up a Windows system and we'll find a place where we can just put in the IP address particularly, right? Then we'll understand how the IP address is constructed and how the IP address looks like and what is the mathematics behind this IP address. Okay, so let's log into the machine. Uh, okay, right click over here. To assign an IP address, we have to go to run. Type in here ncpa.cpl and we'll go to control panel place where we can provide in the IP address. So the shortcut is ncpa.cpl. So your control panel might be not working because of some situation, but this command will certainly work, ncpa.cpl. So right click over here, go to properties and go to TCP/IP v4, TCP/IP version 4. Click on properties and here is the place where you can provide in the IP address, right? So what is the maximum number that you can provide over here? The maximum number that you can provide here is 255, right? The minimum number that you can provide over here is 0. So particularly this numbers range from 0 to 255, right? Now, how do we see this IP address? Right click over here, go to status, and we can see the IP address right from this place. So click on details. So this is the place that shows up the IP address, right? Now, the next question is, how do we see the IP address from command prompt? So just right click over here, go to run, type in here CMD and type in here ipconfig, and this will show you your IP address. So basics are done. So where do you assign the IP address, and how do you see the IP address? So this part is very much necessary in order to understand that what the IP address looks like, and where do we put in the IP address. Let's come back. Okay, so the numbers exactly ranges from something like 55.55. So it has four parts, you can say. So each of the part is particularly called octet. So 255, 255, 255.255. This can be the maximum number. So if you just bring out the binary of this number, it comes to like 1111, 1111, dot 1111, 1111, dot 1111, 1111, dot 1111, 1111. So there are 32 bits in this address. There are 32 times 1 written. So henceforth, an IPv4 address is a 32-bit address. The 32-bit address. Right. So now I hope that you understood why it is a 32-bit address. Since there are maximum 255, so particularly each part contains one over there. So if there are maximum number of ones, so how many maximum number of ones are there? So there are 32 maximum number of ones. So that is why it is called 32 bits. So you can just change this 1 to zeros anywhere in any part of where the one resides. So particularly, even if you change it, it's going to be 32-bit. In that case, right? Okay, so now let's move on to IP address classes. This will make you understand that what are the IP addresses that you can put in over there when you are assigning an IP address, right? So how to distinguish IP addresses on the basis of classes. So let's come to class. Now there are three classes of IP addresses, basically: class A, class B, and class C. Sorry, it's class B here and class C here. Now, class A, I told you that IP address is divided into 4 different parts, and each of the part is called octet, right? So, but the point is that all the classes are distinguished not on the basis of the numbers that we put in octet, but on the basis of the subnet mask, right? So, IP address exactly accompany with a subnet mask. So, if you just put up a command prompt and type in here ipconfig, you will be able to see that all the IP addresses has a subnet mask associated with them, right? So it is the subnet mask that differentiates the IP address class over there. So first of all, let's know the subnet mask. The subnet mask for class A IP address is going to be 255.255.0.0.0. Class B, it's going to be 255.255.0.0. And for class C, it's going to be 255 3 times and 1 time 0. 255.255.255.0. Okay. Now, when we have discussed about the subnet mask, what we have to discuss? We have to discuss about the ranges in first octet. Ranges over there. Ranges in first octet. So the range for the first octet, okay, there is even second octet. So let me make up the columns in here. Range for the first octet, range for the second octet here, and range for the third octet. Or range in third octet and range in fourth octet. So the numbers that vary is that means from here till here it's called a range. I hope that everybody knows about it. So the range in first octet is something like 1 to 126, and range in your class B's first octet is from 128 to 191, and range in class C's first octet is 192 to 233. Okay, so here we go. So for the second octet, so for the second octet, it's 0 to 255. And again, here it's 0 to 255, and everywhere it's 0 to 255. For the range of the third octet, it's 0 to 255 everywhere. So I'll just bring up, drag it over here. Give it a second. Okay, so range for the first octet, is 1 to 126. Range for the second octet is 0 to 255. Range for the third octet is 0 to 255. Range for fourth octet is 0 to 255. The same way over here itself, it is 0 to 255, 0 to 255, 0 to 255. And here it is again 0 to 255, 0 to 255, and 0 to 255. Looking at this matrix, can you tell me that, okay, so how does the IP address look like? It looks like something like x dot y dot z dot a, isn't it? So let me bring my pen, give me a sec. Yeah, here we go. So the IP address over here looks like something dot x dot y dot z dot a. So taking this into consideration, so tell me what is the range for first octet? Or I'll just not range for first octet is already written. So what is the first IP of class A? Of class A. What is the first IP of class A? Write it on the chat, please. What is the first IP of class A? So the first IP of class A is going to be 1.0.0.0, right? And the last IP of class A, I'll just rub this one. I'll just delete this one. So the first, so this is the first IP of class A. And what is the last IP of class A? Last IP of class A is 126.255.255.255. So how is it coming? So it's coming from here. See, so 1 is coming from here. 0 is the smallest number, so it's coming from here. This 0 is coming from here, and this 0 is coming from here, right? In the same way, this 126 is coming from here, the last number. This 255 is coming from here. This 255 is coming from here, and this 255 is coming from here. So this makes the first and the last IP address of class A. So let's see if these IP addresses are accepted. So let's go over here on the machine, and again go back to the place where the IP address is provided. So right click over here, go to ncpa.cpl. Right click here, go to properties, TCP IP version 4, go to properties, use this, use the following IP address. So what was the first IP address? The first IP address was 1.0.0.0. So you can see it from here, and you can see the last IP address from here. So let's put in these IP addresses in here. So 1.0.0.0, right? And this is the subnet mask. It's automatically taken as 255.2.0.0.0. So click on OK. So see here, this IP address is not accepted. The combination of IP address and subnet mask is invalid, right? So in the same way, let's put up the last IP address. Is it taking up the last IP address? 126.255.255.255. And this is the subnet mask over here. So put it in there. So no, it's also not accepted. So what is going to be the second IP address? So first IP address and last IP address of a subnet is not accepted. Remember that. This is what I exactly wanted to make you understand, that this is not acceptable and this particular thing is not acceptable. The first IP address and the last IP addresses are not acceptable. So let's put in the second IP. So second IP of class A is 1.0.0.1, and the second last IP is going to be 126.255.255.254. So let's put in these IP address and see if they pick up this IP address. So again, use the following IP address 1.0.0.1, and here is the subnet mask, and click on OK. Yes, this IP address is accepted. So it is going to start accepting from the second IP address, and till where it will accept? It will accept till it comes up to the second last IP address, like 126.255.255.255. So here it is wrongly written. So see here, it's wrongly written in here. It should be 255 in here. 255.255.254 here. So I just mentioned 255. So this is not going to be accepted. So 254. So click on this subnet mask and click on OK. So this is accepted. So what is the rule now? The rule now is that the first IP address of the subnet and the last IP address of the subnet is not accepted, right? In the same way, if we go to class B, the first IP address of the subnet and the last IP address of the subnet is not accepted. So I'll just jot down the first IP address and the last IP address of the subnet here. So the first IP of class A, it's class B, sorry. It's 128.0.0.0, and the last IP of class B is 191.255.255.255. In the same way, this is not going to be accepted. If you just want me to show you that, let me show you that this IP address is not accepted in here. So if you just go to properties and go to TCP IP version 4, you obtain the IP address over here and just take it 128.0.0.0 on the subnet mask. So you can see that the subnet mask automatically changes. So this numbers in the first octet exactly decides itself that what is going to be the subnet mask. You don't have to worry about the subnet mask over there. But there is a mathematics behind the subnet mask. We'll discuss that in a couple of minutes in there. So now again use the following IP address 191.255.255.255. So this is going to give you this subnet mask, and it's not going to readily accept that. Got the point? Okay, so just I'll click on cancel over here. So what is going to be the accepted IP address, or what is going to be the second IP address that will be accepted over here? Second IP is 128.0.0.1. So it is going to be accepted. And the second last IP is going to be 191.255.255.254. It will be accepted. In the same way, if we come to class C, the first IP of class C is going to be 192.0.0.0, and the last IP of class B is going to be class C is going to be last IP of class C is going to be 223. So it's 192.223. It's not 233. Just mistakenly written. So 23.55.255.255. Okay. So this is, but these IP addresses are not going to be accepted altogether. So 192.0.0.1 and 192.0.0. Sorry, it's 223.223. 255.255.254, that is going to be accepted. Right? So these are the IP addresses that is going to be accepted in here. Right. So I just want you to do a bit of homework in here. Just so take 2 minutes of yours and download something from a website called. So I'll just show you the website. Give me a sec. So go to www.vicesolutionsolutions.in, and from here go to downloads, and from here you go to packet tracer. So this is your packet tracer. Just copy this, Control C, and paste it over there. So you cannot just right click and copy. It's written over there. Use Control C, Control V. So right. So you can just paste it over here and download this packet tracer. Download this packet tracer and install it on your system. So just click on download and install it. Right. So once you have downloaded and installed up the packet tracer, something will come up like this one. PACKET packet tracer. So just you can search it by packet tracer. It's a simulator sort of environment wherein you can drag and drop the objects, and you can design up your network and see how your network looks like, and use routers and switches, and a whole lot of things are there. So I'll just show you that how these systems are going to communicate with each other, or how I will just verify that the IP addresses are going to communicate or not. So you have to click on end devices. So install this packet tracer, click on this end devices, go to generic, drag and drop this on this place. Right now, take up one more end device, drag and drop at this place. So we have two PCs in here. Now click on these switches. So you can see that I am just pointing myself to switches. So click on switches and just click on this 2960, drag and drop this. Okay, so it is not for Linux, it's for Windows. Right. For Ubuntu, we don't have this packet tracer, or might be if it is available on the website, I'm not sure about it, but I have the version of packet tracer that works on Windows particularly, right? Okay, so these are the two machines in here. So now come to connections. So go to copper straight through. So here below you can see that it's writing in here copper straight through. Just you toggle it over here. So go to copper straight through. Click on this one, click on fast Ethernet, and click on this and click on fast Ethernet 0/1. Again click on this, again click on this, again click on this, again click on this, and select it over there, fast Ethernet 0/2. I hope that you understood how to exactly connect these two PCs. Right now, just right click over, click over this one, left click, it's not right click, click on this one, come to desktop, come to IP configuration. You can assign an IP address over here. Like I'll just go and assign an IP address 1.0.0.1. So this is the first IP address of class A, right? So just click on this and click on close. So this IP address is taken. If you want to verify it, come to command prompt, type in here ipconfig. It's going to give you this IP address, right? Now let's come to this place and assign the second IP address of class that starts from 1. I'll not provide the last IP address. I'll just provide it something like 1.0.0.2, right? So it's 101.0.0.0, and this is 1.0.0.2, right? And its subnet mask is 255.0.0.0. Now come to command prompt, type in here ipconfig. You will be able to verify that yes, this is the IP address. You want to ping these two pieces, so type in here and 1.0.0.1. So this is going to ping up this system. So this system is now communicating with this. So your PC1 is communicate. So here it's written PC1. So your PC1 is communicating with PC0 as of now, right? So this is how you will exactly test up and provide up IP address and see that it's going to communicate or not. Okay, guys. So I'm giving you 5 minutes of time, right? So go and download packet tracer on your system and create this scenario, right? So just giving you, okay, not 5 minutes. It will take almost 5 minutes, 2 3 minutes to download. So I'm giving you 10 minutes of time, right? So take 10 minutes of time, download it, and acknowledge on your chat box over there that acknowledge with packet tracer ready. So if you have uh, installed packet tracer ready. So I'm just writing it down. So if you have installed packet tracer, so make it packet tracer ready. PTR for if you have installed packet tracer. And uh, okay, so the website is I'm just giving you the website. Look at the screen. The website is www.vicesolutions with solution with e-solutions. It's called vicesolutions.in. And from here you have to click on downloads, and the whole page will come up, right? And below last one is packet tracer, right? So you have to just go to www.wikisolutions.in. So download packet tracer from there and install packet tracer and try to create this infrastructure in there, right? So your classwork is to, first of all, 10 minutes is only given. So 10 minutes, in 10 minutes you have to just download and install and create this infrastructure over there. So I'm just writing it on note. Give me a second. Notepad. And it is www.vicesolutions.in, and there you have to go to downloads, and from that downloads you will have to go to your install the packet tracer, create the network, and two PCs. This is first of all that you have to do. So packet tracer's link is available over there in www.wikisolutions.in. So I guess that yes, and once you have done this one, acknowledge with ACK with. So ACK means this is the word, this is the keyword that you have to send. ACK means packet tracer PTD. You have to type in PTD. Okay, now your 10 minutes starts now.
Sir, they are asking and tell us for Ubuntu also in that way they are saying.
So Ubuntu, you have to go to Ubuntu might be a payable site. Let me check if you have for Ubuntu or not. Right. So give me a second. I'm checking for Ubuntu. Guys, this link is given on one of the page, but I'm not sure. I haven't tested it. So now the test lies to you, right? So this is for Ubuntu. Right? I haven't tested it, but so it's your you can say call to test the product over there on Ubuntu. Format, font, they'll just increase the font. And please take 10 minutes of yours and solve this. So only 8 minutes remaining. So I think that the guys have started up the work. Guys, once you have done, can you explain what we need to do? Drag and drop the end devices, drag and drop a switch and connect those switches. So if you are done, guys, do one thing, send PTD on yes. PTD is the acknowledgement keyword. Right. So once you have done this one, send a PTD. Acknowledge PTD will yes. PTD means I'll understand that you are done. Don't say I am done, I have this and that. So type in there PTD. PTD will make us understand that you are done. So we'll just short out the number of PTDs coming. So that's like your assignment. Okay. Once you have created the network, so if you complete the task and acknowledge with we see task complete. If you complete the task, then send TC. Just it will not move before 5 minutes. Even if you complete it, no problem. You just sit back and relax. So others are there who are completing the thing. First, we have to create the network. Drag and drop the end devices. Drag and drop the end devices once you have completed the installation. You don't worry about my voice. Don't worry about my voice, guys. Even if I'm not audible, the timer is running. That means the screen is working. Everything is all right. This is the packet tracer window.
Sir, can you tell them once more like what is PTD and TC?
Okay, PTD means you have downloaded packet tracer downloaded, and TC means task is complete. Okay, guys, a few more seconds remaining. I'll give you time to do that. Again, just if you haven't done it, just pause in there, no problem. There's no need to make similes in there if you haven't completed. We'll give you time. We'll give you time. Amit and all, give me 5 more minutes, so I'll give you some time to complete. Don't worry. First of all, we'll have a bit of more exercise in there, and then we'll do that. Yeah, time up, time up, time up. Okay, so let's move on once again over here. Now, see, there is something to be understood. Just pause in there, guys. If you want to understand it properly, listen to the thing instead of just typing in on the chat. If you better listen onto the thing, you will be able to understand it properly. I assure you will be able to understand. Right? Okay. So I'm giving you some numbers: 988967123 4. So 94536127118. 9, okay, 98. So just change 98 723 128 21. 94536215532. 94571 So these seem to be mobile numbers, isn't it? Am I correct? Right. So if you just have a bit of look into this one, this shows that this is from India, right? So 9, right, something like that. This shows that this is from the same service provider 98, and this is from the same service provider 94, right? So what I mean to say, that as you move from left to right, left is a bigger network, while right is a smaller node in there, right? So the left part of the what do you say, numbers exactly make up a network, and the right part of the number exactly make up the node. So same thing about IP address, same thing about your pin code. So I'm just giving you example of pin codes in there. 284001, so let's say, and 284302, so 320, 28767326, let's say, and 814101, 812176, 88270009. So this exactly shows us something like these numbers are particularly from 8, so it's starting from the, it's exactly belonging to the same state. So this is belonging to the same district, I guess, right? So same thing over here. So these two belong to the same state. These three says that these three belong to the same district. Particularly these three numbers say that they belong to the same post office, something like that, right? Or same zip codes. Exactly, we are talking about the zip codes. So if you take any addressing system of the world and you go from left towards right, so left is a bigger network while right is a smaller network. So left we call the network and right side we call the node. Node means individual systems. Like this is the node. Ye node hai. Ye node hai. This is the node. While this whole thing is the network. Got the point? So particularly what I mean to say is that how will you understand? The question is, why did I make you understand this question? The question is, how many systems, just sorry, how many systems are there in my network? This is the question, right? That means let us take up a class C IP address. So class C IP address is something like 192.168.100. Okay, let's take it at 0. So what we have done, so first of all, the class C subnet mask is something like 255.255.255.0, right? So how will you understand that how many network part are there and what is the node part? So as many octets are having 255, keep that octet as fixed, right? And as many octet are having 0, you can change the number on that particular octet. Counterpart, again I am telling you. So let us take the class C subnet mask into consideration. Class C subnet mask is 255.255 uh, 255.255.0, right? And the subnet mask over here says that since there are three octets that is having 255, so what will happen that is that the first three octets has to be kept fixed over there. You can take any number over there, 7.6.33, and change this number, right? But the point is that we are taking up the numbers accordingly to the class C IP address. So 192.168.100.0. So it will change to 192.168.100.1. And it will again change to 192.168.100.2, 3, 4, 5, 6, 7, 8, and it will go on so on and so forth till 255, because the largest number that can be put in the octet is 255. So this number is the largest number and this number is the smallest number that we can put over there, right? So all these IP addresses are in fact like this: 192.168.100.1, 100 sorry, this is the second last IP address, 254. So 1 2 3 4 dot 2 till 254. This IP address is not going to be valid and this IP address is not going to be valid. Why? Because this is the network ID and this is the broadcast ID. This is called the network ID and this is called the broadcast ID, BID, right? So let's see what happens. So I'm just keeping this one aside and I'm taking up one machine in here and showing you the impact. Here we go. So okay, we are here. Run ncpa.cpl. Just right click here. I'll just see that I'm taking a class C IP address, right? So use the following IP address of 192.168.100.0. Okay, 0. First your way 250, it automatically takes this one. So this IP address is not valid because it's a 0 over here, right? This is a network. Since there are three 255s in here, this shows that these numbers should be fixed. 192, 168, 100 should be fixed, and this number we can change because there lies a 0 in the subnet mask at this place. So if you click on OK, it's going to tell you straight away that this is not valid, boss. I'm not going to take up this IP address. Even if you put up 255 over here, this is the last number of that particular octet. This is going to straight away tell you, no, I am not going to take up this IP address. So if you just give the second IP address, that means this one, 192.168.100.1. So 192.168.100.1 and click on OK So this is going to be accepted over there. Now you just come over here, type in here. Okay, so it's already typed CLS clear, and I type in here IP config. And see, the IP address is 192.168.100.1. So what about this 192.168.100.0 and 192.168.100.255? So let's bring out a command called netstart -r. Right. So remember this command, netstart -r. This is going to give you the routing table. So if you just click on enter over here. Okay, so this gives you that, see, 192.168.100.0 is the number available over here, and 192.168.100.255. I didn't ever provide this number, did I? Right.
Sir,
Yes,
sir,
please. Yes, please.
sir, can you zoom little bit? They are not able to see.
But this will become like, okay, let me see. Guys, it will become quite large, right? It will become quite large, and it will just be out of the screen. So if you could bear up with this one. Okay, so here we go. So I just typed in a command called netstart -r. So here we go, netstart -r. This command we typed in, and we got this as our information, wherein this is the IP address. 192.168.100.1 is the IP address, while the above one, 192.168.100.0 is the network ID, and 192.168.100.255 is the broadcast ID. So whatsoever I change the IP, like if I can go to anything, 192.168.100 dot anything will be showing the network ID as 0, and your broadcast ID as 255. So let us change it as 38, something like that. So click on OK, OK, and just test once again. IP config. So this has changed the IP address to 100.38. So let's type in netstart-r. Netstart -r. So see here, this is the IP address, but still this network ID remains the same, and the broadcast ID remains the same. So or till when it will remain the same? Till I make that to 254. So if I just change this to 254, 255 was not accepted, obviously. So if I make it to 254 and click on OK, and click on OK, and just see that IP config, and see that this is the last IP address of this particular octet, of this particular network, you can say, right? So you can see that this is the last IP address of this network, and still the network ID and the broadcast ID remains the same. Now, what is the rule? The rule is very simple, boss. The rule is that two systems will communicate to each other. So just let me rub this one. So what is the rule? The rule is two systems, or I'll just rather say nodes, right? So each place where we put in IP address is called a node. So two nodes will communicate with each other without a router if they are under same network ID. So this is the rule, boss, that two systems will only communicate with each other if they are under same network ID. Right? Got the point? Okay. So why did this one communicate? So this ID of this was 19. Sorry. First of all, let me tell you about the IP address. So 1.0.0.1 was the IP address, and 1.0.0.2 was the IP address, with a subnet mask of what? Subnet mask of 255.0.0.0. And here the subnet mask was 255.0.0.0. So the network ID becomes 1.0.0.0. Why? Because since there is only one part that is showing 255, or the first octet is 255, so we'll keep this as constant and we'll change this one to zeros. So this becomes your network ID. And the network ID of this system is again 1.0.0.0. Why? Because there is 1 to 55, which makes me have this one as my constant value, and we'll change it over here. So 1.0.0, this makes my network ID. So since this network ID are same, this particular thing is same in both the systems. This particular thing is both same on both the systems. So that is why they are communicating. Now let's change the network ID and see, will they communicate with each other? So if I just change the network ID over here, so let's come to this PC, come over here. I'm just changing the network ID a bit. Like I will change the network ID to 2.0.0, or I'll take 2.5.6.4. So this is the IP address. So this is the subnet mask. So this makes that, okay, so come over here. So IP config, not do anything about the zoom because this cannot be zoomed over there. So if you just want me to zoom in, let's see if you can zoom in. Uh, Here we go. So, wait a second. I just typed in IP config and I saw that IP address is 2.5.6.4, right, with a subnet mask of this. But I cannot type in netstat 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 -r to see the network ID. This will not show up over here. In packet tracer, it is not going to show. In real time, it is going to show up over there, right? So, okay, so just zoom in. Okay, so the network ID has changed now, dear. So the network ID of this system, is, so first of all, the IP address of the system is 1.0.0.1, and this is 2.5.6.4, right? With a subnet mask of 255.0.0.0, and here we have subnet mask as 255.0.0.0. So this makes us understand that the network ID is 1.0.0.0 over here, and the network ID is 2.0.0.0 over here. So these two are the network IDs, right? So but the network ID is different. So if the network ID is different, the system is not going to communicate with each other. So let's prove that. Let's prove that the network ID is different. The system is not going to communicate with each other. So I'm just trying to ping and 1.0.0.1. So I'm just zooming in a bit. I'm just trying to ping 1.0.0.1. So it's not pinging. So it's request time now. So what is the rule? The golden rule is that two systems will communicate with each other without a router if they are under same network ID, right? And how to make the network ID same? The number of 255, keep it constant, and the number of part that is having 0, change it. That will give you the network IDs in the IP addresses in the same network ID particularly. So I hope that you guys have understood this one. Just give me a that message over there that if you have any issues. Did you get that? Type it on the chat if you got that. Okay, just a small recap, small quick recap, I meant to say. So for those who didn't understand how to use this packet tracer, listen to this very carefully this time, please. This is the second and the last time I'm teaching you how to use the network in the packet tracer. So click on this one and click on this end devices. See here, end devices is coming up over here. Click on this end devices. Drag and drop one of the PCs from here. Drag and drop second PC from here. Right, drag and drop it. Take this switch and drag and drop 2960 switch over here. So this is 2960 switch, right? So the drag and drop 296024TT. So see there, the number is written. Come to connections. Click on this connection. click on this, click on fast Ethernet, select it and drag it. So if you just click on this one, this is the connectivity that you have to make. It's like virtually plugging in wire, right? So this is how you connect. Now I hope you have understood how to provide in the IP address, right? So this is how we create up a network in there. The point. Okay, so with that, let's move on to something called subnetting, right? So I hope that this IP addressing part is clear, right? But again, we have one more small concept to be taught in this IP address over there. First of all, a small reconnaissance. This is something related to hacking, right? Uh, so how do we? Yes, CLS. How do we find out that what is the IP address of a website? Right? So what is the IP address of a website? So let us say I want to find out the IP address of gmail.com. So just type in here ns lookup and type in here www.gmail.com. This will give you IP address of gmail.com. So can you see that the IP address of gmail.com is 216.58.197.37. Just make a note. Just make a quick note. Take up a small system over there or small, what do you say, notebook in front of you and note down that this was the IP address of gmail.com, right? So we'll require that in a couple of minutes. So I want to know the IP address of facebook.com. So www.facebook.com. So send me your college or any URL that you know, so that I can just put in those URLs over there. I'll zoom it. Give me a sec. I'll zoom it. I guess that it's almost clear now. Okay. Okay. So if you are not telling me, I'm just taking up a random so this is the IP address of your what do you say? Facebook.com. So this is the IP address of your Google.com. So in the same way, www.wipro.com. So let's take wipro.com, right? See, Wipro has got 4 IP addresses. So any website can have even more than 1 IP addresses of them. Okay, so the point is that you can see that the IP address is not starting from some numbers like 10 or some numbers like 172 or some numbers like 192. So you know what, like there are some differences between what the number should be used at home and what is the numbers that's to be used at office. So I'll just make it a bit highlighted in here. Give me a second. So here we are going to deal up with something called IP address used on internet, and here on this side IP used on home or office. So that you cannot use any IP address at home or office, or you cannot use any IP address on internet. So there is a particular, you can say, definition or difference that arises over there, that these are the IP addresses that you can use on internet and these are the IP addresses that you can use over there at your home. So let's take up first of all class A, and then we'll move. Okay, so I'll just capital A. So and we'll then move on to class B, and then at the end we'll move on to class C, right? So here we go, class C. So class A, we know that the numbers ranges are from, so I'll just make up this one. So the class A, the there is a difference in first octet. So rest of the octets are just the same, right? So first octet of class A is something like 1 to 126, right? Out of this, if you want to use it at your home, so if you want to use it at your home or if you want to use it at your office, right? So you will have to use the IP address that starts from 10. So it can be anything in 10.x.y.z, right? If you want to use a class B IP address, so class B IP address ranges from 128 to 191, right? So if you want to use up a class B IP address at your home, so it should start from 172. If you want to use a class, so what it can be 172 dot anything dot anything dot anything. So if you want to use a class C IP address, so class C IP address starts from 192 and still 233, the first octet, 223, sorry. So 223. So if you want to use a class C IP address at your home, so it should start from 192. So the numbers remaining than this one, like the numbers from 1.x.y.z to 9.x.y.z and 11.x.y.z to 126.x.y.z. These numbers are particularly used on internet for a class A IP address, right? In the same way, if you go for a class B IP address over there, you can see that 172 is fixed over here as to be used in our home or office. In the same way, the numbers remaining is 128 dot anything dot anything dot anything to 171 dot anything dot anything dot anything, and what is remaining is 172 is there, so 128 to 172, 172, then again 173. So 173 dot x dot y dot z to 191 dot anything dot anything dot anything, right? In the same way, if it lies for class C is 192 is fixed for your home, so it starts from 193 dot anything dot anything dot anything to 223 dot anything dot anything dot anything. So this is the whole figure in there, right? So since this is the whole figure, just let me come over here to the command prompt once again. So since this is the whole figure, what you will notice that any IP address that you are seeing over here, let me go to properties once again, wait a second, colors, and I'll just use the color. Okay, leave it. So I'll just make it a bit small, wait a second. Yeah, here we go. So if you can just notice over here that the IP addresses of any of these websites doesn't start with 10 or 172 or 192. Look at any of the websites, right? So you go to NS lookup and type in any of the websites that you know, right? You will not find that these IP addresses start with 10 or 172 or 192, right? Now, how do we know that which country uses which IP address? So it's very simple. Go to Google and search for major IP blocks. Click on this one. And this gives you the list of all the countries and the IP addresses that has been given to them, right? Like if you go to click on France, you'll find that their IP addresses in their country. That means if there is a website in France, it will have an IP address starting from 2, it will have an IP address starting from 5, it will have an IP address starting from 31, it will have an IP address starting from 37, it will have an IP address starting from 46, it will have an IP address starting from 51, so on and so forth, right? 62. In the same way, if you just come to India, yeah. So if you just come to India, what you will find? You'll find that we exactly use the IP addresses that starts from 1, 14, 27, 42, 49, 50, 59, and 60, 61, so on and so forth. So many are there, right? So what did we search for? We searched for something called major IP blocks. So major IP blocks gives us the information that which country particularly uses which IP address in there, right? Uh, okay. So I hope that this question is clear. Any question as of now, guys? Okay, no problem. Thank you so much for your feedback. No questions. What about 127? So one of the guy asked me that what about 127? So 127 is a loopback address. It lies in class A, but we don't use that IP address. So since it is a class A IP address, any machine can use that, right? So you'll just exit it from here. And if you ping, so it is a class A. So 127, the first octet has to be fixed. So you can keep it anything, right? So it will ping anything. 127 dot anything will ping. Right. It doesn't need to be existed. It's like a loopback address. It's used for self-test particularly. So that is why 127 has been kept out of the range because we don't want to use that. Okay, so I'm giving you 5 minutes. Okay, 10 more minutes of time. So take 10 minutes of time and do a piece of exercise in there, like use these commands: ns lookup. Okay, type in here first of all IP config, and use this command net start -r. This gives you your network ID. You will find your network ID, NID, and broadcast ID. You will find your network ID and broadcast ID. This one IP config will give you your IP address, right? And wait a second, wait a second. And one more is there, NS lookup. NS lookup. So once you are at NS lookup, you will get this sort of prompt. You type in there www.yahoo.com. So this gives you your, so at this prompt at C:/, let's say C:/, you have to type in NS lookup, you will get this one. So this one gives you IP of. So take up 5 minutes of yours. Okay, 5 minutes would be enough, isn't it? I guess. So take up 5 minutes of yours and do this stuff over there. And once it is done, type in there. Once completed, completed. CP is the code word for this understanding that you have completed. So okay. So now it is your turn, guys. Take up a Google timer. We'll start up 5 minutes of timers. Start. But I'm just stopping the cam for a second. Linux will be taught in the full, that will be the premium session over there. And I don't think that class A is reserved for defense department. So see here, this is a class A IP address and this is on Wipro. So is it reserved for what do you say, defense departments? No, it is not. So it's not like class A is reserved for defense department. I know that 172.16 and 172.31 is in class B range, but the point is that this is just you can say a rough idea of that 172 exactly starts with one or anything that starts with 172 lies in that. So there is a specific range in between them, even that can be used in our home office there. That's a different story altogether. Yes, we are coming to that, how to calculate how many IP addressing in my any range.
So,
Yes,
so there is one question: what happens if we will use the IP address which is not recommended to use?
there can be a conflict in the IP address, right? So if you use this IP address, let us say this IP address, and you are not behind a NATed system over there, so there can be a conflict, right? So that is why we exactly don't use this IP address. So like, wait a second. So like you can we have two systems with same IP address? Can you have two homes with same IP address, houses with same IP address? No, or same IP address. Sorry. Can you have two homes with same address, right? Like 39C XYZ road. We cannot have two homes with same addresses in there, like XYZ road over there, or 46 XYZ road with two different homes having the same address. In the same way, two different systems cannot have same IP address, right? So uh, I'm pretty sure that you are not aware that which IP address is being used by which website, right? So if you are not using a particular range of IP address that is not designated for you, you might create a conflict globally, right? So that is why it is not recommended. That if you use a IP address that is not recommended, you can create up a conflicted environment. So that is why we don't use that. 127 is a loopback address. I said now 127 dot anything is a loopback address. It's used for self-test. I'm giving you telling you a simple small story in there. Earlier, today is the day of mobile. Huh? We use mobiles, but earlier when we used to have landlines. So how to test a landline is working or not? You cannot go to somebody's house and tell that please ring in my phone on my phone. So how do you test that a landline is working? You just press there 161 and keep down your phone, right? So what will happen? Your phone will self ring. So this is something like that. 127.0.0.1, we are self-testing our TCP IP stack, that are we in the network? Is our network working properly? Right. So particularly this is a mechanism to test that whole TCP IP stack is properly working or not. Not that. Wait a second. One second. Okay, where was I? Yes, we were in class A's. We just did a bit of understanding that where exactly IP addresses lie over there and what are the numbers that we can use. Now let's move on to one more question, that how many IP addresses are available in a subnet? How many IP is available in a particular? I'll just zoom in, wait a second. How many IP are available in a particular subnet? Why we'll call it subnet? Every network is in fact a subnet. Particularly, that is why we are calling up this one as subnet. So how many IP is available in a particular subnet? So let us take a class A, right? Okay, first of all, let's start with class C, because class C is smaller. So we will understand in a couple of minutes that what is the reason. So 255.255.255.0 is the subnet mask, right? Last octet or the fourth octet can be changed. So you can make something like 192.168.100.1, 192.168.100. Right, and so on and so forth. You can change it to something like dot 3.4. I'm just not making it the full writing in there. You just need to understand a bit. So 4 and something 192.168.0.3, and so on and so forth. It will just move like, okay, wait. It will just move like, and it will end to 192.168.100.54, and at the end we'll have 192.168.100.255. Right? The point is that here we find that what are the valid ranges? The valid ranges are from here to here. So this is our valid range, right? So this goes green. So this is our valid range, in fact. So how many IP addresses? Okay, wait a second. This whole thing is in the valid range. So exactly this IP address starts from 192.168.100.0, but we cannot use that zero. We know, we have seen that in a couple of minutes back. So 192.168.100.1 to 192.168.100.254. We can use all these IP addresses. So how many IP addresses are there? Simple, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it comes to 254. So there are 254 IP addresses. Now, if you just break up this class C's IP, what do you say, subnet mask into binary, you will find that it comes to something like, okay, I'll just move it a bit so that it's up in here. So this is the binary representation of subnet mask, binary of class C. So 1111 111 dot 1111 1111 dot 1111 1111 dot 00000000. So if you could see here that we have got how many zeros? We have got 8 zeros over here, right? So there are 8 zeros. 8 zeros. So valid IP is equal to 2 to the power of bits off. So bits off means zeros is equal to zeros is equal to off bits. Off bits means what? Zero means either bits are either on or bits are either off. So if you are a computer science student, you will understand that 1 means off bit, on bit, and 0 means off bit. So 1 is on bit, right? And 0 is off bit. So we have 0 is equal to off bits. So 2 to the power of bits off, or what do you say? Just remove this one. So valid IP is equal to 2 to the power of off bits minus 2. Why minus 2? This one is subtracted and this one is subtracted. So two IP addresses are always subtracted, the first IP address and the last IP address. So valid IP will be always 2 to the power of bits of minus 2. So 2 to the power of 8 minus 2. So what is 2 to the power of 8 minus 2, boss? Answer to this question on the chat. Answer to this question on the chat. So what is 2 to the power of 8 minus 2? Yes, very good. Excellent. 254. 254. So you can see, tally this number from here, 254. So we have 254 IP addresses over here. So this proves our axiom that particularly we have as many zeros are off that. So if you just want to calculate the valid IP, 2 to the power of bits of minus 2 will make you understand or give you the number of IP addresses that is available, right? So in the, if this is understood, guys, so how many IP addresses we'll have in class B? So in class B, so just I'll not write in here, I'll just use my pen. So in class B, let's take a class B IP address. So class B subnet mask is 255.255.0.0. So this comes to 16 bits off. 16 bits off, right? So 16 bits off means what? 2 to the power of 16 minus 2, right? This comes to 65534, right? So in class C, we have 254 IP addresses, valid IP addresses, in fact. So in class, what do you say? B, we have 65534 IP addresses. And in class A, how many we have? In class A, I'll just write in here. In class A, we have 255.0.0.0. So which comes to 3, 8, 3s are 24, 24 bits of 24 bits off. So this implies as like 2 to the power of 24 minus 2. So this implies something like 16777,214. So around 16 million IP addresses in here, right? Around 65,000 IP addresses in here and around 254 IP addresses in here. So this is your whole figure if you just take up the default subnet masks. So these are the default subnet masks. So see here, there is something to be understood. 8 bits of 254. More number of bits of more number of systems. The more number of bits of more number of systems. So if you want to have lesser number of bits of, that means lesser number of systems. That means if you just don't want 254 IP addresses, right? If you just don't want this sort of IP addresses to be there. If you just want to connect, let us say, 4 PCs in here, right? Or 6 PCs in here. So is it suggested to use these IP addresses? No, it is not suggested to use this IP address, in fact. Why? There is a reason behind that. We'll come to that. I hope that this is understood, guys, that how many systems can be connected using a particular subnet mask. It is clear, isn't it? Okay, great. Now, let's take in up a small issue in here. This gives us 254 IPs, but I don't have 254 PCs. So my question is, I do not have 254 nodes or computers, nodes/computers. I only have, let us say, 4 computers to be connected, right? Or I only have, let's say, 6 computers to be connected. I only have 6 computers to be connected. So in this case, so the case becomes, what subnet mask should I use? This is the question, right? I only have 6 computers. So you don't need 254 IP addresses. Now, some of you might say, so I'll take 1, 2, 3, 4, 5, 6. That is it, done. I'll leave rest of them. Okay, that's okay. You can do that. But there is a challenge here. What happens is that you will have to understand something called broadcasting. What is broadcast IP address? So let us say that there is a computer over there. So this is your computer. This has a IP. So here is your computer, and this has an IP address of 192.168.100.100. Okay, 100.50. So this is the IP address of the system, and the subnet mask is 255.255.255.0, right? So this IP address can also be written as 192. Can also be written as 192.168.100.50/24. So what is /24 here? /24 is on bits. So if you look at this subnet mask, if you look at this, if you look at this subnet mask, there are 24 on bits in here, right? So this is how a subnet. So if you can just write it this much big over there with a subnet mask, or you can just write it this small, 192.168.100.50/24. So this is the on bits. So this particular value is called CIDR value. Got the point? So we already have written the IP address and slash the CIDR value. Okay. So now the question exactly remains the same. So if at all I have to connect 6 computers, can I give this IP address? You can give this IP address, right? But there is a challenge there. What is the challenge there? The challenge is that whenever this system will come up into the network, it will try to find out when it comes up. When it comes up means when it is started. Comes up, it will search for 254 PCs. Why? Now the question is why? Because its broadcast ID is 192.168.100.255, which says that it is belonging to a group wherein there are 254 PCs. So if you take up this IP address, since its broadcast IP address is this one, it will broadcast this into the network, and it will see that, okay, fine, how many IP addresses could I connect to? Could I connect to all the IP addresses particularly? So this will unnecessarily create, you can say, traffic in the network, right? So I don't want that much of traffic. So in order to segregate the traffic, what we will do, we'll just crank down the number of systems that is required. So what do I mean by cranking down the system number of systems required? So instead of putting it something like 8 ones over here, and then 8 ones over here, and then again 8 ones over here, and then again all the zeros over here, I'll do something like this one, right? So this is the change subnet mask. So how many IP addresses this one will give? So 2 to the power of 4 minus 2, 2 to the power of 4 minus 2. So it's something like 2 to the 4 to the 8 to the 16 to the 32, right? 2 to the power of 4 is equal to 2 to the 32. 32 minus 2 is equal to 2 to the power of 4 minus 2 is equal to, guys, what is the value? 14. Yes. So it will give you 14 IP addresses. Now I don't require exactly 14. So how much I require? I'll require, let us say, 6 IP addresses. So I'll just 2 to the power of bits of minus 2 is equal to 6. So this becomes our formula, right? So this is the number of systems required. So 2 to the power of bits of is equal to 8. So 2 comes over here, so 6 becomes 8. So 2 to the power of 3 is equal to 2 to the power of bits of. So cancel this one off. So bits off is equal to 3. So I'll make 3 bits off and rest all the bits on. So this is our subnet binary representation of subnet mask now. Got the point? I hope that you understood this one. That how to bring out the subnet mask over there for the number of systems required. So just let us take one more example. So you require, let us say, you require 14 IPs, right? You require 14 computers to be connected. So how will you exactly formulate the find binary of subnet mask? Okay, I'll just take up a white sheet in here. Here we go. So your question is, I need 14 valid IP, right? So what is binary of subnet mask, right? So let us take it, what is binary of subnet mask? Okay, yes, correct. So 2 to the power of bits of solution is 2 to the power of bits of minus 2 is equal to 14. So this becomes your solution. So this implies 2 to the power of bits of is equal to 16. So 2 to the power of bits of is equal to 2 to the power of 4. So just cancel this off. So this implies bits of is equal to 4. So therefore, subnet mask is 1111 dot 1111 dot 1111 dot 1111 0000. So why 0? Because this is coming from here, 4 bits off, right? So let's calculate the subnet mask for this one. So this becomes 255, this becomes 255, this becomes 255, and this becomes how much? 1111. So I'll just calculate it for you. 1111 0000. 1 2 4 8 16 32 64 164 128, right? So just 4 8 plus 4 12 13 14 15. So the whole is 255 and minus 15, right? And how much it becomes? 240. So this is the subnet mask, right? So this is the subnet mask over there that we require in order to connect, what is it, 14 systems over there. So I hope that you understood, isn't it? How do we find the subnet mask? That means we require 14 systems. So I'll just mark it one more. So what was the question? We require 14 valid IPs. So what is the binary of subnet mask? So we found the binary of subnet mask, and after that we found the actual subnet mask over here. So this is the actual subnet mask. So this is how we calculate the subnet mask. Okay. So now here is your question. I'll just delete this one. Calculate subnet mask for 50 nodes, and number 1, calculate subnet mask for 62 nodes, and question 3 is calculate subnet mask for 124 nodes. And take the nearest value. If it is coming in points, take the nearest value. Give me the subnet mask. Give me the subnet mask. I don't need that 2, 4, 5, 6. Give me the subnet mask. Okay, so your timer starts now, guys. You are given 10 minutes of time. Because why it is so? Let me just, okay. Instead of coming over here, let me give you an example that why do you require to understand this one. So I am just giving you, I'm just showing you 49. This is the IP. This is my router, right? So I'm accessing my router. So my ISP has given me some IP address here, right? So if I want to find out that how many computers are there in the network that my ISP has particularly given. So how will I find it out? Just let me. Okay, here we go. So you can see that this is a default. This is not the default subnet mask. 255, 255, 255.192. So how will I calculate that how many computers are exactly connected, right? So until unless I find out this figure belongs to how many computers, so I will not be able to calculate that. So that is why this experience is particularly required in order to understand that how many computers are there in my network or how many computers can be connected. So your timer starts now. So I'll just take it around 10 minutes. 10, 0. Okay, so if you have any questions, please put up in between. If you have any questions, please put up in between. CIDR, Sandeep, is the number of bits on. That is it, nothing else. CIDR is a value. That means if the subnet mask is 255, 255, 255.0, that means 24 bits are on. So slash 24 is the CIDR value. Just don't type in like slash 25 slash 26. Type in there for 50 nodes we require, this is the subnet mask. Type in this way. Shubhajit Sahana, you can use anything. It's not like that 192.168.x.y. You can use 5.6.7, but this is an example. That is why I'm showing you over there. Yes. Samin Pandey, you are correct. For 50 nodes, we'll require this much, I guess. So this is how you should answer. But malware your answer is more reliable was 255, 255, 255.192. 255, 255, 255.128. Yes, Surendra, I didn't understand your question. How do you find the last answer? Uh, I didn't understand your question. For 50 nodes, you can take it to the nearest number, like 60 over there. So 50 nodes. 50 nodes exactly, it will not come something like 2 to the power of anything minus 2 is equal to 50. It cannot be there. So what you will take 50, so it comes to something like 54, right? 52. Rest of it nearest power to the complete power to the 52 you will have to take. For 50 and 62, it will be same. Manish Kumar Santoshi, you can use your calculator. Open up calculator. There is a binary to digit, what do you say, decimal to binary or binary to decimal converter in there. So you can use that to convert your binary to decimal. If you don't know how to change it to binary, just use a calculator for that. Sundar, I got your question. Okay, so see here, how do you find an IP? How do you change that? So let us say, okay, take it here. So let us say that this is 11111000. So at the end, so it is, just remember this: 1, 2, 4, 8, 16, 24. Sorry, 1 to 8, 16, 32, 64, 128. Right. So these are the numbers: 1, 2, 4, 8, 16, 32, 64, 128. So 4 plus 2 plus 6 is equal to 7, right? So the total is 255. So subtract 255 minus 7, because this is 0, this is 0, this is 0. So subtract this one, so you will get your answer. Got the point? 255 minus 7. So this is how it is calculated. Yes, Rajat, your ideology is correct. When we take 62 IPs for 50 nodes, there will be 12 unused IPs, or we can further restrict them. No, we cannot further restrict them. There will be 12 unused particularly. So we cannot just avoid completely, but there will be 12 unnecessary broadcasts, you can say. But still, they will have lesser than 254. So a few more seconds remaining. A few more seconds remaining, guys. Time is up. Okay. So for those who haven't understood this maths, no, not to worry. Just go to Google and type in your IP address calculator. Right. So I just taught you the whole formula to make you understand that where is the science coming from, right? So, but there is a IP address calculator, and I like this one, www.calculator.net. Right. So go to IP subnet calculator. Right. Now take up any IP address.
Sir, your camera is off, sir.
I can understand that. I can understand that. Sorry for that. Yeah. So here we go. This is where was I? Yes, I was at this point that how to calculate a subnet mask. So we have a IP address calculator here. So this is at calculator.net. So you don't need to do much. Just go to Google it out, IP address calculator. You will get calculator.net over there. And let us say you want to calculate for a class C. So we'll start up with class C. So class C, 3 octets are fixed. So we'll take 192.168.100 or 192.168.150, anything you can take. 150 dot last octet can be changed, so make last octet 0. Now, just from here, these are all the ones, all the CIDR values, like /32 is all the bits on 255, 255, 255.255. /31 is 1 bit off and rest of the bits on. /30 is 2 bits off. /30 29 is 255, 255, 255.248. /28 is 255, 255, 255.240. /27 is this 26, 25. So you want to, let's say, find out that what will happen if I just take up /27. So you have put in the IP address, you take up /27 and click on calculate. So this will give you that, see boss, this is the subnet mask, and the number of hosts that is available is 30. Number of usable hosts is 30, and the number of total number is 32. So why? Because first and last is gone. 0 and 31. 0 and 31 is not usable. 0 and 31 is not usable. And look over here, you'll get a very nice chart. So this is the binary representation of the subnet mask, right? This is the binary representation of the subnet mask. This is the CIDR notation. So /27. So /27 is nothing, but it's the number of bits on. So you can see here, CIDR notation is nothing big science. It's another number of bits on. Now here is the real essence in here. So what happens is that this is giving you a table in here. So this table shows that this is your first subnet, this is your second subnet, this is your third subnet. So what do I mean by subnets? That means all the IP addresses from 192.168.50.1 to 50.30 will communicate with each other. 192.168.50.30 will not communicate with 192.168.50.33. 192.168.50.33 to 162 will not communicate with 65. Provided you have given this as the subnet mask, this one. 255, 255, 255.254. So let us do this experiment in here now. So go over here, go to packet tracer. I'll just scroll down. So what is the subnet mask? 255, 255.255.254. So what I'll use this particular subnet mask. I'll use this particular subnet mask. Okay, just drop it out. So this is the subnet mask, and I'll use 2 IP addresses from this block, wherein this is the network address, this is the broadcast address. I will use 2 IP addresses from this block. I will use 2 IP addresses from this block, right? And see which of them are exactly communicating with each other, right? So let's go to packet tracer and find out the actual essence of subnetting. So this particular methodology is called subnetting. Why it is called subnetting? So see here once again. So it contains all the IP addresses. It contains all the IP addresses right from 192.168.100.50 to 192.168.150.255. But it has been broken into different blocks over there, and each of the block will communicate with each other. Like this first block will not communicate with second block will not communicate with third block will not communicate with the fourth block, right? So let me mark it over here once again. Here we go. So I just want you to see the subnet mask and IP address, both of them at the same point of time. So this is here, the subnet mask, and this is the first block, this is the second block, and this is the third block, right? So let's go over here and take up this packet tracer. Take up this end device, drag it. I'll require 6 PCs for this one, right? I have to test. So this two, and obviously this two. I'll take up this one over here, right? I'll connect it. So all of them are connected via the same switch over there. Okay, so all of them are connected. Now let's give this IP address. So I am giving this IP address from the first block. So the first IP address is 192.168.150.1, right? And subnet mask is 255.255.255.224, right? Just let's close this one now, right? So let's go to command prompt, type in here ipconfig just for your convenience. Okay, ipconfig. So this is the subnet mask, right? Just let me close this one as of now. Just close this one and close this one, not required, and close this one as well. So I'll just go to this one and go to go to desktop, go to IP configuration, and I'll put the last IP address. So you can give anything, 50.1, 50.2, 3, 4, 5, 6 till 30, right? So 192.168.150.30, and this is the subnet mask. Okay, so this has to be changed to 224. Close it, close it. Done. Now let's go to this one and come over here, go to desktop, IP configuration, and we'll take it from the second block over here, 192.168.50.133. Yeah, 50.133. 192.168.50.150.33. And this is the subnet mask. Close it, close it, and here we go. Desktop IP configuration 192.168.150.62. By 255.255.224. Close it. Did I give 224 over here? Yeah, I gave 224. So let's keep this one from the third block. So here we go, IP configuration and 192.168.150.65. Subnet mask goes like 224. Close it. Close it. And here we go once again. Desktop IP configuration. 192.168.150.84. Yes. And this 224. Okay. So done. We're done. We're set. Right? So just now let's ping the systems and see till where it is pinging. So I am pinging from the first PC. From the first PC's IP address is this one, 50.1. So let's ping this. So now a few of you guys asked me a question. What is ping? So in phone we have ring to test the connectivity. In computers we have the same way ping to test the connectivity, right? So ping and 192.168.150.30 is communicating with 30. Excellent, great, right? So let's clear the screen. Okay, see, clear is not working. Okay, this is not a computer, sorry. And 150.33 is going to communicate, is it? No, because this is in a different block, right? So 33 to 62, they'll communicate with each other. Just let me just show you one second. Okay, so we are at which IP address? We are at. Okay, so it's already 33 written in there. So why should I see it once again? So let's do 192.168.150.62. It's communicating with 62. But will it communicate with 65? It communicate with 65? Oh, it's not going to communicate with 65. It's not communicating with 65. Why? Because 65 is in a different block. So this is particularly called subnetting, guys. That keeping everything in the same switch, what has happened is that these two systems are isolated, right? These two systems are isolated, or any other IP address that we keep in this over there. So these are all isolated networks over there. They will create segregated amount of broadcast in there. Thereby, our network will be secure. So what? There is a safety point from that. If you look at it from a cyber security perspective, what happens is that if I just keep the number of IP addresses segregated, there will be a hacker who wants to use an unused IP address. He can use unused, not use that, I mean to say. Right. So if we have 14 systems, so let us keep only 14 IP addresses in that case. But what about 50 systems? So obviously 12 are wasted over there in that case, right? So we have to use some sort of firewall or something to block up the packets in there. But still, the network is segregated in that case if we exactly divide the network into small segments over there. Okay, so I am over with my session over there. So what is the wait. What is the next session over here? So the next session is your introduction to ethical hacking and lab setup. So we'll go towards ethical hacking lab setup. But before that, I would like to find out that if you have any doubts over there. Is it clear, guys? So take your 5 minutes of time. I'm just giving you a Google timer over there for 5 minutes, and just use this IP calculator. Okay, I will give 5 minutes. Okay, no problem. Let me start over here and insert IP calculator. Or you can take down the IP this one directly. But where did it go? So it is calculator.net, right? Go to calculator.net and you can calculate the IP address. Calculator.net. So your timer has started over here. Okay, go ahead. You can use any 192, 168, 150 was just an example. You can use class A, class B, class C. So this is what is VLSM. VLSM stands for variable length subnet mask. That means when you are changing the length of subnet mask, we are changing the length of subnet mask from 25 bits on to 26 bits on to 27 bits on to 28 bits on to 23 bits on. So this particular methodology is called VLSM, variable length subnet mask. That means the length of subnet mask is changing over there.
Sir, there is one question by Satyam Virat. So, sir, if we are on different subnet in bracket host range, we can't access the other range system.
Yes, we cannot access the other range systems. Correct. This is what I was taught in just a couple of minutes back. That if you are using up a different subnet over there, let me take it this way again. So, yeah. So if you are using different subnets, so these subnets are all different from each other, right? So they are all different from each other. So we cannot exactly ping these two.
Sir,
There is
Arun Kumar is asking, sir, how to connect to different network.
that we will learn. That we will learn in a premium session. Okay, we
So
use
what is
routing for that. You
sorry,
need to have sorry.
what is the difference between A, B, C? They are asking. Class A, B,
What is
C.
it? So just let me show you. See, if you take up a class A subnet mask, so what will happen that the number of this is increasing over there. So if you are picking up class B, this is the one. That means you can use it from slash 16. Okay, you can use it from slash 16 at the bottom to slash 32. So if you're in class C, you can use lesser than that. You can use it from slash 24 to slash 32 over there, right? So the point is that as you go towards class A, you can have more number of systems. So see, the subnet mask is 255 dot dot 0 dot 0. But this is irrelevant, boss. This is irrelevant. You can use any number over here. So if you just take up class A and you can select, okay, I'm just taking up class A IP address and class C. Class C's IP address and class A's closely subnet mask over there. So I'll just take up, let us say slash 10 and calculate it and see what will happen. So see here. If you take up class C's IP address and class uh, A subnet mask over there. So this is what is going to happen. You will have more number of nodes. See, there are very many nodes in there, right? So if you just go over there, straight up to the table, what you will find is that number of hosts are these many. See here, these many hosts you will receive, right? And these many are usable in fact. So only two has been subtracted. Got the point? And this is the subnet mask particularly. So this number is irrelevant. This number is irrelevant. Right, this number is irrelevant. This is of nothing. You can put any number over there, any number. What is the one that is making the things change over there is the subnet mask. हिंदी में बोल दे, IP address वो माया है. IP address is nothing. The one that is making the changes is the subnet mask. Subnet mask भगवान. Got the point?
Sir,
So we can do anything.
yes,
Right.
sir. So there is one more connecting question. So we intentionally fill all available IPs in a host range in a subset. Then we are safe from attacks by any hacker.
Can you just copy down the question once again and paste it over there so that I can see?
Uh, Sir, it's there on our StreamYard. I copied in the private chat.
Okay. So we immediately fill all available IPs in our subnet and we are safe from attacks like any hacker. So this can be a from a hacker's perspective. This is again a hacking style even that you fill up a network with all the available IP addresses and the network is gone. right? Or you can even be safe in that sense that you use all the IP address. But you can say that how will you use all the IP address? There are 16 million IP addresses. So particularly if, see here, once you go deep down now, what you will find that take one system here and take one system here. Connect these two via a same switch and take the subnet, take this IP address 192.168.100.5, let us say, with a subnet mask of 255.255.255.0, and take up this system with IP address of 192.168.100.20, let us say, with a subnet mask of 255.0.0.0. So as of now, you can understand with this experience that this is valid. This can be done. So the network ID of this system becomes 192.0.0.0, and the network ID of this system becomes 192.168.100.0. So this network ID lies beneath this network ID. So these two systems can communicate. Got the point? So this particular methodology is called supernetting. So this is beyond the scope, but still this can be used by a hackers in some malicious, for some malicious tricks particularly. So we can fill up the IP addresses if required with some arbitrary subnet masks. D class is not used because D class is used for multicast, right? So D class is used, in fact, by switches for internal communication. If you have got two Cisco switches, so this is your Cisco switch and this is your Cisco switch, right? And this is your Cisco router. So how will these three communicate with each other, right? So we cannot give 192.10 something over there to communicate between these two. So for internal communication between these devices over there, we use some IP addresses. So that the IP address is our class D IP address, which is called multicast IP address, right? So which is used for internal communication. Internal communication. Okay. Vikas Jaiswal, the basic of IP, basic of or the starting of hacking is to understand all the devices and all the IP addresses related information that lie between these devices particularly. So IP address is the starting. If you don't understand IP address, you cannot start. Yes, networking is very essential. Without networking, understanding of network, you cannot exactly do this task, right? Okay, so now a bit of classwork in here. We have, it is almost 21:15, so we have got 45 minutes of session officially remaining in here. So what you have to do, you have to use up IP calculator, right? And you have to create up this sort of network. You have to create this sort of network. You take your own choice, take your own network, right? And create a network of your choice. So I'll just not tell you what to create. This time I'll just not tell you what to create. You just create a network. Create 3 subnets in fact. So create 3 different subnets and connect them via same switch and see that they do not connect to each other. So this is your task. So I know that most of you have done the packet tracer, but there are so many who haven't done packet tracer in this group over there. And you have got time as 45 minutes. So you take your time, ask me questions if you have. I am here to answer to this question, right? So I'm just starting up the timer now. So Harsh, would that be okay for these guys? Isn't it?
Yes, sir, definitely. Am I audible, sir? Hello?
Yes, yes, you are audible, loud and clear.
Yes, sir, definitely. It will be fine, sir. Yes,
We'll
sir.
have some tasks to work on, and they can ask me some questions even if they like. So you have got
Yes,
timer
sir.
running.
So I'll help you out.
Yes, you help me out because there are certain times when I'm not able to see the screen, right? So you can help me out to find out the
Correct.
question that is relevant.
Okay, sir.
This is not an assignment. This is a classwork. Yes, this is an assignment. You can say that as a classwork, this is an assignment. So, yes, sir, should they submit something over there or somewhere as an assignment? Sorry, Harsh.
Sorry, sir.
Harsh, this is an
Sir, I
assignment,
think
right? So, do they need to submit somewhere this assignment particularly?
sir, they can submit it on our assignment link, which will be there in the description.
Okay, okay. Okay, so one of the guy reminded me over there. Just I missed up something. Just hang on for a second, guys. So what to set up the lab? You have to download three things over there. So go to the same website www.wikisolutions.in. Wikisolutions.in. Go to downloads over there, and here you will find uh, VMware Workstation 15, right? So this is what you have to download. This is VMware Workstation 15. This is what you have to download, right? So keep it downloaded. We'll just set up the lab next day. And you have to download this one, Windows Server 2016 B-Box. So should I share it on chat over there? Should I share it on chat?
Sir, so the submission form is Google form actually. So there we were taking the links and also,
Okay,
can you guide them like?
we'll take care of that assignment submission next week. This week, let them do the classwork. Right, this week, let them do the classwork. We'll take their assignments
Okay,
next. We'll take that. So I have
okay,
sent
sir.
the
So today,
links or link to that these downloads over there, VMware Workstation 15 and what do you say? These three machines: Windows Server 2016, Kali Linux, and VBox. We need these three VMs for what do you say? Hacking. So you download all these three machines and keep them dumped on your system. So you have got 1 week of time to do that. So next week I'll just show you how to use this in particular.
sir, you can send me here in StreamYard also. I'll update it in description box below.
Okay. I'll just do that. Give me a second.
Sir, so this week there will be no assignment, right? Next week we'll give them assignment.
Yes, next week we will give them assignment. Let them do some you can say classwork particularly, so that they feel that they have learned something.
Definitely, sir.
Okay, so I have just sent you two links. I'm just sending you. I have just sent you one link, and I'm sending you the second one. See that these guys are getting that posted on their relevant systems, right? And they have to
Okay, sir.
download the content over there. So I have sent you on that screen here.
Yes, sir. We'll update it on the drives description below, sir.
Yeah. So Mac Oracle VirtualBox, you have to download this Mac Fusion. So Mac Fusion, you can directly download it from www.vmware.com. Yes, you can use VirtualBox instead of VMware, but the machines has to be set up properly. And I am not using VirtualBox, so you will yourself be responsible for setting up the virtual machines. VirtualBox is okay. I'm not denying that, but the point is that I am using VMware Workstation, so you will not be in sync with me in that case. IPv4 is a 32-bit address and IPv6 is a 128-bit address. The IPv6 uses only hexadecimal numbers for IP addressing. So there is a different mechanism for that. Harsha, I am audible properly?
Yes, sir. Yes, sir. You are audible.
Trupti Khatri will see that how your laptop is not supporting, but just keep that downloaded, right? And VMware workstation and all. So once you keep that downloaded, we'll see that how it is now.
Sir, they can refresh their YouTube, so it will be showing them in the description below. I have added the two links.
So you can refresh your YouTube and the download links are there in that description there. Yes, if you have your VMware and VMware Workstation 15.0, so that is fine. Okay, Ganesh. VMware Workstation 9, these machines are not going to work on VMware Workstation 9. These are all newer machines. We require VMware Workstation 15. Yes, the next session is on weekend. So every weekend we have a session. Saturday, Sunday, we have the sessions over there. Red Hat Linux is not used for penetration testing, so we cannot use Red Hat Linux as of now. So once you are accustomed to the packages, you can understand how to download those packages in Red Hat Linux. But as of now, as a beginner, you cannot use that. There are no classes on weekdays. Red Hat Linux is not okay. You cannot use Red Hat Linux. Metasploit is for the premium subscription.
Sir, they are asking that should we only download and keep it, or we need to install it also?
You will if you are able to install it, it's okay for me. I don't have any objection. But if you are not able to install it, at least keep it dumped on your system. But see that the original files are not just messed up, right? You create a copy of those files.
Sir, is Parrot OS is suitable for future lecture because I use Parrot OS for my daily use and I don't have Windows.
So in that case, you can download VMware Workstation for Debian from www.vmware.com and then use these machines over there.
Sir, I already have VirtualBox and it's set and working fine, and it also has Vonix integrated to it. That
Uh,
okay? It's that okay?
See, VirtualBox is okay, but the point is that you will not be in sync with me. I am not sure that how much you will be able to work on VirtualBox because I don't have VirtualBox in my infrastructure that I will be sure. I have VMware Workstation. So what is suggested is that you use VMware Workstation.
Sir, do we need install Kali Linux, or live version of Kali is okay?
Live version of Kali is gone. It is now no more available. So this is Kali 2020 live version of Kali is not there. You cannot run Kali live.
Sir, there is one question. Let's see if we can do. Sir, please can you tell once more how many machines we required, please?
So we require three machines. One is Kali Linux, another is Windows Server 2016, and another is BBox. Right. So particularly three machines are required in this case. So you should have at least almost around 8 GB of RAM on your system. 4 to 8 GB will be working.
Sir, will 4 GB RAM work fine for lab?
It will not work fine, but somehow you will be able to work on that. Recommendation is 8 GB.
Sir, how to keep? Okay, sir. Sorry. How to keep backup of my system, and then how to install VMware?
To back up your system, you will require take up a system restore point, or create a system restore point. Just go to Google and find out how to create system restore point. Right. So create a system restore point and then install VMware Workstation. No, you don't have to pay for VMware Workstation. That contains keys. The keys are there.
Yes, sir. Sir, will you teach steganography? STEGANOGRAPHY.
Premium level.
Okay, so we'll teach them in advanced version, right? Advanced and premium version, right? Yes,
Yes,
sir.
yes, advanced and premium.
Okay, sir. So let's do in this way. Then we can just brief once again what is the task they need to complete, and we can end the session till there. So they can submit it on our form, or we'll work on the submission part. We'll make that available in the description.
Okay, so this is the task. They have to create 3 subnets and connect them via same switch and see that they do not connect to each other. So this is the task.
Okay, sir. Okay, sir. So will it be feasible to submit that on Google form?
Yes, obviously. Why not? Why not? At least they should submit the screenshots and type in the IP addresses properly. Let us see that how they are able to send the assignment, right? So we'll help them out next week, but let them do the self help over there this week, right? Okay.
Okay, so they, yes, sir. Let them check on their screen. Let them try once, and
Yes.
then we can give next week. We can give them for assignment. Okay, sir.
Yes,
That
yes.
will be
You can
fine.
save this. See, guys, if you can see my screen, you can save this whole network in the form of packet file over there. File, save as, and you can just save it somewhere like I'm saving it in on desktop. I'll name it as test network. Network. So this is saved over there. So even if I close up packet tracer now, so okay, yes, and if I just open up packet tracer, I can just load up the whole network from the system. Okay, so file open, and on desktop I saved it, I guess, right? So on desktop, so it is test network. So this is coming over there. So either you can send up this file, or you just upload this file on Google Drive and send us the link to the Google Drive on the place where sir will tell you to submit. Right? Would that be okay, Harsh?
Yes, sir. Definitely.
The third machine was
Okay, sir. So,
B-Box. B-Box is a penetration testing machine. You cannot go and hack anybody. The point is that you learn a machine where you need to learn how to hack. So B-Box is a learning machine where you can learn how to hack. B-Box. No, B-Box. B-E-B-O-X.
sir, is there any
Okay.
major difference between VMware and VBox?
VMware is an application that is used to virtualize an OS, while B-Box is the virtual machine. So those two are entirely different things.
Okay, sir. Then shall we end the session over here? They can try this out and they can work on it. We'll
Yes, Harsh,
check
why
them
not?
in the next
So
session there.
yes, okay. Obviously, we can have an end to this session. So, thank you guys. Thank you so much for being with me. I hope that this has been informative for you. See you next weekend. Till then, bye bye. Have a nice day.